Good afternoon, folks. We're going to give a couple minutes till about 1 p.m., but welcome to the webinar today. Okay, it's just turned over 1 p.m., so let's get this going. Good afternoon, everyone, and welcome to the third and final webinar in this particular series on Understanding Radon. Today, we're going to be looking at radon-resistant new construction, and Bruce has a whopper of a presentation for us. So I'm really excited that you're here. And before we really dive into it, just a couple housekeeping. If you've been here before, just wanted to remind you that we're recording the webinar and we're looking to make them accessible on our website in the future. Everybody will be muted, but if you have any questions, feel free to raise your hand. It's in the panel below, and we'll unmute you if you'd like to ask a question at any point. And at the end, we're going to have a period of time for questions and answers. So please use the Q&A panel, and we'll make sure we get to as many as possible. If you do enter the webinar as anonymous and we don't get to these questions today, Bruce will follow up with you, but we will need you to provide some contact details so that he will follow up with you directly with any answers to your questions. So just make sure you've got contact details in there if you'd like answers to those questions. If you do run into any technical difficulty, logging in and logging out of Zoom, out and in tends to figure it out for you. But if you have ongoing issues, feel free to email us, learning@echo.ca, and we'll do our best to help you out. And lastly, we'd really appreciate 3 minutes of your time to fill out a survey. It'll pop up on the end when the webinar ends. And that really helps us to make sure we're providing valuable webinars for you all. So just a little bit about ECHO. We've got 3 main areas of expertise. So if you could just switch onto the next screen there, Bruce. Thank you. So no, all good. So we've been in business since 2000, and we've got service hubs in Mississauga and Ottawa, but we do serve the entire nation right across Canada with over 75 employees and a lot of professional accreditations. We're really focused on 3 main areas of expertise. So environmental compliance, excess soil, environmental site assessments, hazardous materials, so asbestos and lead, and then occupational health and safety, which our expert today leads that division, and they do a lot of indoor air quality, mold, and last but certainly not least, radon, which is what we're going to be talking about today. So we're going to be covering a variety of things. I'm going to let Bruce kind of give you the down low on all of that, but just to give you an idea of what to expect, we're here to learn about the standards, the updates to the building codes that are coming into effect soon. And there's some really interesting case studies that Bruce has to share about where things have gone wrong. I want to introduce Bruce briefly to you. He's got 15 years of experience, particularly in radon, and he's a member of the board of directors for Karst and a registered assessor. He's passionate about radon and dedicated on staying on the edge of all of the technologies that are coming out and all of the updates to the regulations. And so without further ado, I'd like to introduce Bruce to tell you a bit more about these updates. Thanks, Bruce.
Thanks, Naomi, and thank you everyone for joining. I'm just going to add to the introduction. My background is civil engineering, and I'm a building science specialist. So when it comes to code and construction, I can speak about that in some reasonably intelligent manner. So When we're doing this presentation today, I'm hoping that you had the opportunity to join us for the first two, so that you'll have a little bit more understanding about radon and where it is and how we test for it and the health effects of it. So I'm not going to get into that primarily here, but if you did miss those webinars and you want to backtrack and review them, as Naomi said, they're available on the website, so please feel free to do that. This one is focusing primarily on new construction methods and how to basically build radon out, for lack of a better term. So if you're a non-building construction person on this, I apologize, but I'll probably be maybe talking about some terms that are unfamiliar to you, but I'm hoping that the audience has some basic understanding about construction. But fair, you know, fair enough. If not, I will make sure that I promise if you leave a question and we don't get to it today, I promise you I will respond. Just let me know who to respond to, and my contact information is available. So feel free to email me as well. So this is just a radon introduction, but how it relates to new construction. So really quickly, why should builders and developers care about this? Well, I've been doing this for a long time, and if you do this right, it'll save you time and money and reputation. If you do it wrong or you don't think radon's a problem and how to build it, it's going to cost you, right? And most of the builders that I've wound up working for wind up hiring me because it's cost them, and they want to avoid that. So radon and radon-resistant construction has been in building code for a very long time, since at least before 2006. So I was at the OBOA conference, which is the Ontario Building Officials Association conference yesterday. There was a lot of discussion about, oh, radon's finally in code, or now it's in code, or there's the code changes. I've done an intense review, and not a lot has changed because it's already there. The ambiguity of where it applies and where it doesn't apply has primarily been removed. And national code and provincial code blend fairly well. So it's there. It's been in code, and it's a code requirement to do radon resistant construction with very few exceptions. If you're in Ontario, you have a huge liability issue. Radon in residential construction is covered by Ontario home warranty for up to 7 years post-construction. So you're on the hook for that if you're a builder, right? And if you haven't dealt with it properly, it's going to cost you a lot more dealing with it after. Okay. It's far less expensive to do this stuff up front and then pass those costs on to the purchaser. If you don't do this up front and you're caught with a Ontario warranty claim, all the fixes come out of your profit. I had one builder got a Ontario warranty claim, and this is going back 12 years. We helped him, we fixed it. He found out that he was on the hook for 7 years, and he called me and he says, I did the math of all the building stock I had out there, and after I threw up, I decided I was going to change how I do stuff, because he realized what impact that could have to his company. Okay. You can market a healthy building, which everybody's interested in at this particular time. Okay. So building radon or building radon out at the beginning is a lot less expensive than a retrofit. Doesn't come out of your profits. It's far less time consuming. If you're doing retrofit radon work, it's disruptive to the occupants, which causes them to be dissatisfied, right? They get the impression that a builder did a terrible job and exposed me to this cancer-causing agent, and now they're repping up my house to try and fix it. Doesn't really bode well for you. So radon is one of the silent killers. We all know carbon monoxide is the other one. But what is radon? It's radiation. It's that simple. It's in all buildings. You can't see, smell, or taste it. You don't know how much is in the building unless you've tested it after the building's constructed. You can't figure this out beforehand. And it causes lung cancer. It causes 3,200 lung cancer deaths in Canada per year, which is 85 times the deaths from carbon monoxide residentially in Canada a year. So we should really be putting our money in radon control. And if you have high levels, it needs to be fixed. Now, don't get me wrong, I'm not saying that we shouldn't put things in carbon monoxide protection, and it is tragic if a family dies from carbon monoxide exposure. But if radon's not controlled in the building, that same family is going to die of radon exposure, has the potential to die from radon exposure. It's just spread out over a longer time, so it doesn't seem as tragic, so it doesn't get as much attention. The real tragedy is that every other family that lives in that house for the entire lifetime of the building is being overexposed and potentially killed from lung cancer. So radon enters the building through stack effect primarily, or pressure differential. If you could see it coming through the floor, this is what it would look like. They put some stage smoke underneath. Or at the other presentations, you've seen this, but it comes into the building. And we're talking incredibly small pressure differentials, what most mechanical designers would classify as insignificant. Got this question too about hotspots yesterday. There's no place in the country that's radon free. And I've had several buildings test over in areas that are geographically defined as, radon low potential. So there's a map. You can't use the map to decide to not build radon resistant. Never have been able to, can't do it now, and it never will be allowed to do that. If you're not familiar with radon, the cutoff limit or the action limit from Health Canada is 200 becquerels, and a becquerel's a nuclear disintegration in a second, so a tick on a Geiger counter. So that's 200 ticks on a Geiger counter in a second, right? But with all cancer-causing agents and with all radiation, we want to get that exposure as low as reasonably achievable. So we get it as low as we can, even though 200 is the legal limit. And when it comes to building radon, it's more than just about geography. Certainly, if you're sitting on a source of soil that's got a lot of uranium in it, as opposed to you build in an area that doesn't have a lot of uranium in it, yeah, you're sitting on a source that's weaker. You're going to have less radon. That makes sense. But it's so many other factors, the construction methods, the construction materials, the quality, how deep is the foundation? Does it puncture different stratas of soil? The HVAC system, do you have a heat recovery ventilator? Is the heat recovery ventilator maintained? Is it properly balanced? The heating methods, such as radiant versus forced air. What do the occupants do? How do they operate the building, right? Wind forces, renovations. So that's why Health Canada says build radon resistant, right? And test, because it's the only way to know. I got questions of, can you determine where the radon is before you build, and if you need to put in these systems? That's a question that people have been trying to answer for decades, and I can tell you that the state of Florida spent $150 million trying to figure that out, and they found out that they could not come to any realistic, confident correlation. And the cost to test and determine or try to determine whether you should or needed radon-resistant construction was more than actually implementing the radon-resistant construction. So there you go. Okay, so the principles of radon control are pretty simple in general. We want to limit radon ingress. So we do that by applying sealants and barriers to our building. Now, if you think you can just seal the radon out all by itself and it's going to work by itself, I'm pretty much going to guarantee you that's not going to work. You might be lucky on the odd occasion, but it's been proven time and time again to not work. What we want to do is decouple the pressure from the soil and the house, right? So we want to make sure that the soil gas isn't getting sucked into the house. And we can do that by some rough-ins, which we'll get into in more detail. But if that still doesn't work, we want to be able to reverse that pressure differential. We want to put some suction underneath the basement floor so that we can, for lack of a better term, suck the radon out, or negate that stack effect that's pulling it in, basically reverse it. Now you can do ventilation. A lot of HVAC designers like to go to ventilation because that's their wheelhouse. They don't typically get into subslab depressurization. And you can pressurize a building and you can use dilution to get rid of radon. But you're building a more robust ventilation system to deal with that. If you want to drop your radon level in half, you got to double your air changes. So lot more ventilation, a lot more energy loss, lot of maintenance, reduced life expectancy of your equipment. So what is all this radon resistant construction about? You could also use the term readily remediable construction. So if there's a problem there, how do we fix it easily and readily? And so both those terms can be used synonymously, but really it's all about turning a negative into a positive. So instead of the building being under negative pressure sucking the soil gas in, you flip that around and then you suck a little bit of conditioned air out. And you can see that very effectively demonstrated with the smoke pencils here. So the general components of good radon resistance in new construction, these are general, and they're not, you know, not necessarily limited to what I'm going to say, but if you have these points in your construction, you'll be in good shape. So sealing the foundation penetrations, and that includes cracks in walls and floors. If you've got masonry block walls that penetrate into the soil, you need to make sure that you've sealed at least one of the courses in there so that the soil gas doesn't come through the block walls. Seal the slab perimeter, so that's where the floor touches the wall. You need to seal the centers of your hollow metal columns or hollow steel columns, or concrete columns, concrete block columns. You need to seal the sump pits. That's a huge entry point for radon. Put a soil gas membrane underneath the slab. Okay, that serves two purposes. It retards the fusion of radon, but if there's a crack in the floor, you've got an air barrier underneath there. And it also keeps your concrete from getting into your soil gas collection layer. So it serves a lot of purposes. And remember that radon getting into a building isn't so much about diffusion of how much is diffusing through the concrete. It's more about mass transport. It's about the soil gas billowing through the floors and the floor cracks and getting into the building. So it's just the same as an air barrier, keeping moisture out, except for keeping out soil gas for the building science people in the crowd. So we want a gas collection layer underneath, and usually this is clean gravel. And I know that's not always the case across the country, so I'll give you some options for that later on. But you need free air movement underneath the slab so you can effectively depressurize. You want the pipes roughed in, ready to go, so that it's easy to connect them. You want to label the system, right? Because you want people to know what it's for. You don't want somebody to mistake a rough-in as a sewer pipe and connect a toilet to it. Don't laugh, that's happened. Um, and you want to test for radon when the house is constructed or the building's finished being constructed, because then you know if you have a problem or not. And then you can activate the system if you do have a problem, and that's putting in a fan and depressurizing it. But another good thing too is foundation sealants. So we're talking damp proofing, waterproofing, or gas proofing, and they're not always the same. Okay. There's several regions in Ontario and some places in BC that have radon in their building process. So their building authorities have actually come up with a program to help builders implement it. And I helped Guelph design theirs. And again, that's been in place for a long time because it's been in code for a long time. It just wasn't really clear, right? So what these building authorities did was they came up with a system to tell the builders what their options were in code to help guide them through radon and build radon safe communities. Okay, so now we're going to get into code. Now, don't worry, I promise I'm not going to pull out individual code clauses and go over them because that would be nauseating detail and drive everybody crazy. But I'm going to talk about National Building Code and Provincial Building Code in Ontario, because Ontario was a little different on its own. And of course, we're an Ontario-based firm, so I'm sure I'm going to get a lot of specific questions about that.
Bruce,
National
if I can
building,
just pop in for a second. Sorry,
sure.
we've got a question here from Michelle. If I can just ask Michelle to briefly state that about the previous
I
question.
don't see anything in my question and answer screen.
Yeah, she just raised her hand. Michelle, if I
Oh,
can
here.
maybe get you to pop your question into the Q&A, that might be a little bit easier to do, or we'll do the unmuting at the end.
Oh, I think she's asking for continuing education points. Yeah.
That sounded like it was an anonymous attendee question, so no worries.
Okay.
Please continue. We'll deal with that later.
Okay.
Thanks,
Sure.
Bruce.
Absolutely. Okay. So National Building Code 2020, and we're talking about the Ontario Building Code in 2024, which comes into effect 2025, January 1st. I've heard and it's been announced that Ontario is adopting National Building Code in its entirety in 2025. That's great. I'll believe it when I actually see it. So until then, we're going to go with what we have here. But fundamentally, if you're in Ontario, your radon-resistant construction mirrors almost identically what's in National Building Code. So it applies. Now, if you're interested in all the places where it's referred to in code, take a quick screenshot of this screen. This is all that I will really get into in details with code, because again, I don't want to bore everybody with all the requirements, okay? But this is where radon would appear in code. And as you can see, it parallels pretty closely Ontario or provincial. A few tiny differences, and the fact that Ontario has their own supplemental building design document in SB9 specific to radon. But the key thing is, regardless of the clauses and the specificness of the clauses, code is a health-based document. And OH1 and OH 1.1 clearly say that you have to build a building that isn't going to cause harm to people, and it specifically states indoor air quality is part of that. So you can't get around the objective of the code, right? I'm going to talk about this in Ontario because I got a lot of questions about it yesterday. There's 3 designated areas in Ontario where SB9 applies, and that's here, Elliott Lake, Algoma, Faraday, County Hastings, and Township, Hayman, and Territorial District of Sudbury. Somehow, this got into people's heads that these are the only places in Ontario that require radon-resistant construction. This was never true. It's not true, and nor will it ever be true. They changed this clause to say in the additional requirements laid out in the code for radon-resistant construction, in these areas, you will follow SB9. And SB9's been changed a little bit, but basically, if you're following all your other requirements in code, you're following what you're going to need to do in SB9. There's lots of places in Ontario that were way higher in radon prevalence than these 3 areas. These 3 areas are in here because they were mining communities or are mining communities, and the workers that went to work underground and were exposed to radon needed a rest pit at home so they weren't overexposed to radiation. Big reason why they're in here. But these are not the designated areas. Well, they are the designated areas, but don't think that those are the only areas where you have to do radon-resistant construction. So if you're from Ontario, that's probably the best takeaway I can give you. There's an exemption in code that you don't need to build radon-resistant construction if the building's not going to be occupied for 4 hours a day or more. Makes sense. If it's a pump housing building or an electrical transformer housing building or something of that nature, nobody's going to be in it 4 hours a day. They're not going to be overexposed to radon, so it doesn't make sense to go through the efforts and build radon resistant. But if there's also a clause that if you do change the occupancy of the building, that you can mitigate the radon by ventilation, which is also true, as we've talked about. I'm just going to give you some caution with this. This is clearly a case-by-case basis. So as a developer or an owner, before you make the decision to not do radon-resistant construction, because you meet this clause requirement, just make sure that you've taken into account the risk and made a good decision for you. Now, radon-resistant construction isn't just in residential. There's a lot of focus on residential. It's covered under Part 9 in code in residential, and it's very prescriptive, as residential code always is. But it also applies for industrial, commercial, and institutional buildings. And that all falls under Part 6, which the professionals then design for. And it falls under good engineering practice and required ventilation. So National Building Code and Provincial Building Code reference this US EPA document for schools and large buildings. And I'm going to just touch base on that a little bit on the next slide. But if it's ventilation, ASHRAE 62.1 requires you to make sure that the indoor air quality is acceptable. So those are the 2 that apply to, commercial buildings, schools, hospitals, etc. EPA 625, great document. It's old though, 1994. There have been other documents that come out that, in my opinion, are better and give some better options, but this is what's in code, and this is what you have to follow. I've done design with the newer design documents and just done the math to show that we comply with this. So I can help you with that. It covers the basic requirements. You get both ventilation, a means of controlling radon, but also pressurization. So it's a good document, great place to start, even though it's old. It it covers all the basic key components that we talked about. But when you're talking about where you discharge your radon exhaust, the radon that you're sucking out from the ground, it's important to realize it says it has to be 25 feet from an intake. That's excessive, but it also contradicts other places, and we'll talk about that in the future. So if you're following various designs, you still have to comply with both of them or figure out which one applies. For commercial buildings, unlike residential, you quite often have various sections of the foundation that are split up by walls or um, grade beams, or where the footings break up the floor area in various places. So this document is good at explaining how to make sure that when you put in your subslab depressurization, or you put in your piping or your suction pits to collect the radon from underneath the ground, gives you some really good ideas how to do that. Because you have to suck the radon out from every corner underneath the slab. Because if you don't do that and you don't have the suction everywhere under the slab, you won't get all the radon. Okay. So ASHRAE 62.1 talks about general air quality, a very broad document, very well written document, and it gives you 3 ways to manage indoor air quality, right? And I'm not an HVAC engineer, so I'm not going to get into a lot of those details. But this document had caused some consternation for some of our members when they're trying to design systems, and the mechanical engineers focus on this. If I can say a few things, this standard, or this document, was never designed or written to specifically address radon. So that's where a lot of the challenges come from. It classifies radon as a class 4 air, which is basically high enough in a concentration to cause harm. So this is really meant for like industrial processes, um, laboratory fume hoods, things like that. ASHRAE doesn't define what the radon concentration is for class 4. So by default, it goes to the authority having jurisdiction. So here it's Health Canada, so it's 200 becquerels or less. In the United States, it's 148, so you have to pay attention to that, right? So when you're putting in your radon suction system and you have to put your discharge point out, Table 5 of this document says it has to be 30 feet from an intake, which contravenes or contradicts the US EPA document. So which one do you use, right? And again, that's excessive. Health Canada and CGSB have done research, and clearly 3 meters is acceptable, or 10 feet is acceptable clearance from a intake. Okay, and if you do ASHRAE's calculations under normative appendix B, you can demonstrate that that's 3. But typically people tend to go to, the 30 feet because that's the maximum. They think they're getting the best protection. Can cause a lot of problems. Okay. CARS has researched this. We've talked to ASHRAE. We've received confirmation on this, so we can help if you run into those problems. And the other thing with ASHRAE, there's the no test and conformance proof paradox. ASHRAE 62.1 doesn't require you to test after you built the building. Doesn't require you to test for radon. So you don't know if your HVAC design worked or not. I've tested lots of commercial buildings all over the place that would have been designed to this standard, and they exceed 200 becquerels. Well, under ASHRAE's document, you're not permitted to recirculate class 4 air. It has to be exhausted straight outside. So any building that was built that followed this document and recirculates or has a concentration of radon in the building that's greater than 200 becquerels clearly didn't conform to this standard or the building code. So, and again, this document was never designed to deal with radon specifically, but that's some of the loopholes or conundrums that you can get into. All right, National Building Code talks about rough-ins. So this is putting the pipe in the ground to make sure that you can suck the radon out if you need to. And these are some details provided by National Building Code. They're good details. I have a few things to point out. You'll notice here, and hopefully you can see my pointer, that the the piping is inserted directly in the gravel. And what a lot of our mitigators have found over the years is these get plugged up with gravel. And then when they try to put suction on this, they don't get any suction or don't get enough suction. So you want to have some free space around this gravel when you put these in. Build an air plenum, a suction pit, a pocket that you can depressurize. Dramatically increases the efficacy of these systems. And the other point I want to draw out in code is it shows the membrane coming up and being sealed pretty much at the top of the slab. Okay. The reality of that is this is what you get. You get the poly coming up above the slab and it's all crumpled and wrinkled, and you get all these tiny little flow channels for the radon to come up. So this actually creates a worse situation than if the concrete were to just be poured flat up against the wall and you put a bead of caulking on top. It's another example where they tried to trim the membrane and put caulking on, and that's just, you can't get in there. It's terrible and it's not working. So this is a better solution, and if you were at the OBOA, you might have seen Mr. Radon's mock-up of this. If you seal the membrane to the footing, and then you put some caulking at the junction, or then pour the slab, and then put some caulking, this is a much better practice. This is something that will work much better. Okay. So Canadian General Standards Board. So we've talked about the basic requirements of what's in a radon control system, and we've talked about the code requirements. It's about maintaining that continuity of the air barrier through the basement so that you're not sucking soil gas in. And if perchance you don't get that perfect and the radon's high, what do? We can simply just put a fan on the pipe and suck the radon out. We're done, right? As opposed to a whole bunch of costly additional retrofits and dissatisfied customers. So that's generally how this works. Now, the Canadian General Standards Board has a radon standard for radon-resistant new construction. I was part of the team that reviewed this. It's a pretty solid document. It's not specified in code, but it's a great resource for you to go to. So we're going to touch base on just the details, the drawing details, I mean, so that you can wrap your head around it. And I focused on the drawings because the pictures are worth 1,000 words as opposed to reading boring code clauses. So it's CAN CGSB 149.11, and that's fresh this year. Okay. It has requirements. It has a gas permeable layer, which is typically clear gravel underneath the floor slab. You can use a gas mat or various things if gravel isn't available in your region, and we can talk about that. The soil gas barrier underneath the slab, I mentioned it serves a bunch of purposes. Instead of being just 6 mil polyethylene, we're recommending 10 mil. It's just a little bit more durable, stands up against the construction traffic better. It has piping under the floor, but it also specifies a suction pit, right? Or an excavated pit. That's because we know it dramatically increases how it works. So don't fall in the trap of not putting in a suction pit because you'll have to abandon your rough-in if you don't have good connectivity. Sealing the entry points. The rough-in of the vent pipe, it's 100 millimeter diameter PVC, and fans if the home's over. So it breaks it down into a few different rough-ins. I'm going to touch base on those. The level 1 rough-in is in the interior, and it's very similar to the details we saw from National Building Code. You can bring the pipe up through the floor, seal the cap on it, you're done. Or you can plan where the route's going to go if you need to exhaust, and you can put it out through the sidewall. Now, if you do that, it's very important that this exterior also gets sealed. Okay, this is still a rough-in, right? If you're doing a 2B rough-in, it's still a rough-in. It's just the pipe coming up and going out to the side. It's not an active system. This stub up through the floor is not an active system. These will do nothing to stop the radon. They're just there if you need them. My preferred method, and this is required in BC in various places, is a full height rough-in, right? And it's running the pipe all the way through to the roof. Exactly the same, basically, as you would for sewer gas control. This is a schematic out of the CGSB standard, and basically, if your Doing a level 1A or 1B rough-in, you're getting very low radon resistance. It's any radon resistance you're getting there is strictly from the sealing that you've done. If you go with a passive stack, you're getting a medium reduction because you're already decoupling the pressure and you're letting the radon vent somewhere. And if you go to 3, which are active systems, you're getting the maximum protection because you're actively keeping the radon out. When Guelph came out with their system, they had sort of 3 options available, and the builders wound up going just straight to full active systems because then they could close their building permits. They went with the most protective system. They could cost it out. They could put it in. They could demonstrate it worked. So even though there was resistance at the beginning that they had to do this, they went with the more expensive option because in the long run, they realized it saved them money. So these are just some of the details out of the CGSB standard that you can reference and look at. The one on the left here is the stub rough-in, and it runs through a pipe and it goes to a suction pit or a cage, which we'll explain that. It goes to the center of the building because it makes sense, right? Pressure is going to radiate out. This other one is the same concept, but there's a loop of perforated pipe that you run around the foundation. Either one work. Both work really well. There's pros and cons to each, and depending on what you want to do, but those are 2 options. One of the things I want to note is if you look here, the caulking is below the slab. The poly is finished below the top of the slab. This is the level 2B rough-in, right? And again, it's the pipe that goes to the pit or through a loop, either one, comes up and exhausts out, or sorry, penetrates through the ring joist. This is a sealed cap. The benefit for this as a builder is at least you've planned where the pipe's going beforehand, right? That's important. I'm going to get to that in a second. But the reason why you have to keep this sealed is if you get a positive wind blowing this way on the building, you're actually going to pressurize underneath the slab and push more radon in the building. We have actually seen this happen on a builder that installed what they thought was a passive system exhausting out this way. Okay. So this is if you're going to go active, right? But it needs to be sealed here. Why is it important to look at this as an option as opposed to the previous one? Too many builders, very high quality builders, have called me out and they've put in a rough-in the center of multi-unit residential townhomes, underneath the stairs, in the mechanical room, which is in the center of the building. So now it's high, the radon's high. Now they have to take that rough-in through a finished basement to the exterior. So they're ripping out drywall or they're building bulkheads, they're disrupting that process. Imagine the cost associated with that if you're a builder, as opposed to having this already there. And the other one with this one, it was a townhouse. So when you punched the piping out the back or out the front, you were limited to where you could put it, right? Because it had to be so far from an open window, so far from a door, right? And if you know how congested a townhouse is at the back or the front, the routes that the piping had to come out just looked horrible, right? Or it was directly above the garage. So then the option was to run up through the center. And of course, now you're going through the kitchen, you're going through the bedroom, you're ripping out drywall, you're putting the pipe in, you're insulating the pipe for sound, all post work. You're repainting everything. Okay. So if I can advise builders of one thing, think about where you're going to put the pipe, run it out, because then it's done, right? You might have it on your plan where you're going to run it, but when you go back to fix it, it might not be there. So that's why I really like this system from a saving builder money perspective, but also health related. Okay. This is a pipe, just like a sewer gas pipe. You run it straight up through the building, preferably no bends, because then you're going to get that natural draw, that natural stack effect that's going to depressurize a bit underneath the floor and keep the radon down. You can see radon reductions of about 50% when these systems are put in properly. Okay. So already put in. And if the radon's high, you just go and you size the radon fan, you go up in the attic, you fire in the fan, or if you've got a spot to put it downstairs in here, you fire in the fan and you're done. You're done. And all this cost is included in the purchase price of the home. I'm not going to go into these in details, but if you're a builder or a building science person, CGSB has a lot of really great details that have been well thought out on how to fill or how to finish those joints and how to detail those joints for various types of construction. Okay. There's a good number of them there. Um, you can go back and review them with the recordings here, or you can look them up in the standard. But there's a lot of good stuff here that you don't get in code. So that's why it's a great resource for you. We talked about the multi fittings, or sorry, multi footing separations where your soil gas would be broken up, your gas collection plenums. So this would be your strip footing that your walls would sit on. You need to connect the pipe so that you can draw from both sides. Okay. You can't dig this stuff up later and fix it. So take the time when you're putting this down to make sure it works. This is one that I inspected and it just got crushed. So, we had to replace that. But take some care. Pick the right materials. This was just big O slammed through the footing. I recommended something more robust. The builder didn't want to do it, so they had to replace this. Okay. Rough rule of thumb, just to help you out, if you've got a good suction pit and well set up soil gas collection plenum, one suction pit can do about 3,000 square feet. Okay. But if you do it wrong, you'll get a fraction of that. And I've seen that in small residential footings where they've done poor construction and you don't get anywhere near that connectivity. So you have to put on a bigger fan or another draw point. Okay. So take your time. CGSB also gives details with crawl spaces on how to connect the membrane to the wall and then put piping to collect the soil gas just underneath the membrane. So if you're looking at getting into the details, this will help out a lot. Okay, but there is a standard, so you don't have to make this stuff up. And if you make it up and you get it wrong, you haven't conformed to the standard. So just go to the standard. You'll get the information. CGSB tells you about piping requirements. Minimum, it's 4-inch inner diameter. Schedule 40 pipe needs to be strong enough to withstand some punishment. And various materials, it lets you use just about anything. So just go to your code, your local code, and make sure that you've met all the other building requirements. The pipe needs to drain 1% back to the soil. You're pulling in a lot of humidity from the soil, and you need to drain that water back to underneath the slab. If you don't, it condenses in the pipe, and you can't build any P-traps. So this is one where builders put the fan above a P-trap. So all this filled with condensation and they drown the fan and wrecked it. Okay. So another thing is you're supposed to pressure test the stack to make sure it's airtight. So, and when you put in the rough in, the full height rough in, they give you some clearance discharges and some nice geometry pictures so that you can put it the correct distance away from windows and doors, things of that nature. So this is for a passive system, right? So a passive full height stack. If you have to activate this, you're fine. You're golden. You just stay with these. If you're putting in the side discharge as an active system, you got to go to the other CGSB standard, which is 012, because the clearances are a little farther. Because if you're popping out the ring joist, you need to pay attention to that. And you can see here, there's nothing that's bigger than 3 meters. So you'll find that these are very close to combustible gas meters coming out. This is sometimes where things go horribly wrong. Think about where your pipe's going to go. Think about where that's going to exhaust. You want to make sure you're not exhausting where they're going to put the kids' sandbox or where they're going to put the patio and have barbecues, because you're going to have higher concentrations of radon coming out of there. You just want to think about where you're putting it. So use some common sense. There's some labeling requirements on what you label. On the pipe, C-NRPP has labels, pre-made labels that you can purchase that meet the CGSB standard and building code. Okay, so you want to label the barriers if it's on a membrane in a crawl space, because somebody needs to know that they can't rip that membrane up. You want to label the pipe. You want to label the rough ends. You want to label the sump lid because you need to seal the sump lid. You don't want a plumber pulling it off or a homeowner pulling it off and not resealing it, right? So things of that nature. And electrical panel, so you know which spot the fan is, where the radon fan is. And if you activate the system, a label to identify the radon fan. Okay. I know I'm getting tight on time. I'm going to speed this up, but I want you to get all this information. I told you it was going to be fast and furious and and condensed. There's some specialty products that help you out. IPEX has something called Radon X. It meets all the requirements for residential. So off the shelf, good to go. If you're doing it for commercial buildings, the above ground pipe for Radon X doesn't meet the flame spread requirements, but IPEX has a workaround. You can get the pipe you need that's XFR and does meet the flame spread, and they'll provide you with the stickers. So if you want to use this in commercial, the below ground stuff, you can use it. But the second you got a fire issue, you got to go through some other loopholes, but IPEX can help you with that. Okay. And they've got some really great custom attachments that are beneficial here. Kafka, for the Canadian Urethane Foam Contractors Association, they have various spray foams that actually are air barrier, vapor barrier, and rated as a radon barrier. So you can spray the spray foam underneath the slab and against the wall and use that as part of your system. And they've got a bunch of details to meet all the other things, the piping underneath the slab, the gravel underneath the slab. So a good system, right? If you don't like spray foam and you want to go with a more manual method, Owens Corning has come out with their formula radon system, and they're using solid sheet insulation, but they've got the details pinned down properly on how to seal it properly. I've reviewed the system, it's acceptable. So just depending on what you want to do as a builder, right? These are the suction pits I talked about. Radon West pre-manufactures these. I've spec'd them in several of my jobs. They come in small, medium, and large sizes. The one on the right will meet the schools and large buildings requirements of US EPA, and that can do up to about 10,000 square feet of space if you've built the rest of it right. But one of the smaller ones for residential construction, I think well worth the investment. If you don't have gravel in your area, or clear stone to draw radon through. There's other products. Radon Guard and Radon Block is one of them. I saw another one at the show. Unfortunately, I'm sorry I didn't have the time to put it in here or remember the name of it. But you've got your underslab insulation, and it's elevated with all these pockets for soil gas to move underneath. And there's a custom one that allows you to drop in your draw pipe and meet your suction requirements, and off you go. So very good if clean gravel is impossible to get or incredibly expensive in your location. And they have their own radon barrier. It's really heavy, it's really hardy, and they use that with their system. Okay. You can use soil gas clear mats to, if you don't have gravel in your area, just keep in mind that these have a lot of resistance on the fan and you have to build a heavier fan. Okay. And spray application on the outside, or you can put in sheets for radon control. If you use a bentonite type material, it does not have good radon resistance. Usually it's a bituminous type material. There's a couple of products out there, Trim Proof 260, ePro, and they allow you to co-spray. And what this co-spray, I believe calcium chloride that goes with the bituminous spray, and it will turn into this rubberized material that you can actually build up quite thick. That's good because it'll stop cracks, or it won't stop cracks, but it'll seal cracks if they develop. If you just put up dimple board and you say you have damp proofing, you do have damp proofing, but dimple board without any type of layer like this will do nothing to stop radon from going through a crack. Okay. So think about what's necessary and what you need. Okay. And if you've got a drain where you're draining to the ground, you don't want the soil gas coming in. There are custom drains or proprietary drains that you can buy that fit any type of drain that allow the water to go down, but don't allow the gas to come up. Okay. And I know I'm tight for time, Naomi, but I think I can blast through for a few minutes if you'll bear with me.
Go for it, Bruce. Any questions we can always answer by email later. Thanks.
And I see Fadi from IPEX has posted a tweak in the question and answer. I won't read that because I trust Fadi. He knows his radon stuff, but he's the IPEX rep, so he knows his product better than I. But these are mistakes we've seen. You need some professional oversight like anything else, right? I don't work on the brakes on my car because I'm not a mechanic. And if I tried, it would be a disaster. These are all things I've seen with Guelph's system and dealing with builders trying to help with that. There's two types of concrete that's cracked and the concrete that will crack. You could deal with this with injecting resin or urethane after, but if you've sealed it or if it's behind a block wall or sorry, a finished wall, good luck with that. So keep that in mind. The worst one is people confusing pit run gravel with clear stone. So you get pit run, it comes in and it's got fines in it, and you're not going to get any air movement through that at all. So bad news for the builder when they had to excavate it all out by hand and put in clear stone. Fans, radon fans, they go vertically because they allow the water to drain through. They are not permitted to be put sideways. That's wrong. And you get rubber couplings. You don't actually solvent weld the fan to the pipe. This one, builder did everything great. They nice pipe setup, thought it through. Problem is the spot over here where the couplings are, where the fan's supposed to go, there's no way the fan's going to fit in there, right? So they did their best, learning mistake from here. But think about it. If you got to put a fan, where's the fan got to go, right? Think about how big around the fan is. And another key thing to remember is 4-inch inner diameter pipe is about 5 inches outer diameter. So 4-inch 100 mil pipe does not fit in a standard 2x4 wall. This is just poor construction, poor workmanship. Pipe's at an angle. The pipe wasn't properly supported, and you can see the rubber couplings crushing under the weight of the pipe and the fan. Leakage points were terrible here. The worst was they had to pressure test the system to make sure that the pipe was solid. If you're going to do that, you need to do it without the fan installed. They flooded the fan and destroyed the fan, as you can see by all the water here on the floor. Okay. This one, the building inspector passed, right? Here's the radon system. It's in doing what it's supposed to do. Bathroom basement, the tub, they put in the drain pipe. Plumber busted a hole in the floor to get the alignment right, normal practice, and they just left it because that's the way we do plumbing, right? They would have depressurized the furnace room here because all the pressure would have gone through this hole, and they could have downdrafted the furnace or caused a carbon monoxide issue. Same thing happened here with a shower that's up against the wall. You can't get behind it to put in the spray foam. At least they tried part of it, but they're still going to depressurize behind the wall. So just not thinking it through. Leak by, if you don't find a way to manage it, it's just going to cause the air to leak and be a problem. So that's ripping out the entire basement wall and redoing it. Commercial buildings, if you got the expansion joints for your concrete, that's a radon leakage point. You have to figure out how to deal with that. Just poor consolidation of the concrete behind the pipe, so terrible leakage point. Yes, you need to put poly in contact with wood that's on concrete to protect it, but imagine you can see all the pockets here where the radon's just going to billow through that construction. So you need to figure out a way to seal that. It's just somebody being lazy with the caulking. I guess they forgot there was a back part of the pipe here. So they only caulked 80% of the pipe. And again, I mentioned, think about where your piping's going before you have to put it in, because if you don't, you wind up with some code clearance issues and you wind up with some really ugly, awkward fixes that can cause other problems. So thinking about where your pipe's going is important. So we're doing all right. I'm getting back on track. So in summary, radon is in every part of the country. Radon-resistant construction is in code, and it has been for a long, long time, and you can't get away from it. Every building needs radon-resistant construction some way or another. Builders carry liability. You're responsible for the fix, right? You don't want somebody coming after you and saying, you let radioactive cancer-causing gas get into my house. It's not your fault. The building's there. The radon's there, right? So it's not really the builder's fault. I try and convince homeowners of that. But if you don't do what you're supposed to do in code, then technically it can be your fault because you haven't found a way to fix it. And again, if you're in Ontario, Terry, in 7 years, what would you sooner do? run in some pipe for about $1,000 or $1,500, and you can pass that on to the homeowner, or spend $3,000 to $7,000 fixing a problem in every single house in the same area. That's the kind of difference in cost you're looking at. Experienced professionals, C-NRPP professionals, can help you with all these pitfalls. They can reduce your build cost because they understand what needs to be done. You can avoid the rework. That's where the cost really lies. Okay. They help ensure compliance. We can discuss with the building officials. Is it a 25-meter discharge? Or sorry, 25-foot discharge? Is it a 30-foot discharge, or is it a 10-foot discharge? We can help with that because we have the experience in the background. That reduces your liability, right? And C-NRPP has a specific course for radon-resistant new construction. So, all right. Sorry it took a little longer. There was a lot to cover, and I wanted to make sure everybody got the key bits.
Absolutely. Thanks, Bruce. We have one question here, so now is your time. If you have any questions, pop them in the Q&A, and if your name is there and we don't get to them, we'll absolutely follow up with you. So the first question by Ina, Bruce, can you talk about creating the negative pressure using an existing sump pit? For example, if the building construction wasn't radon ready.
Yes, that was covered in the second webinar, but sump pit depressurization is something that you can use. And you can tie into all the weeping tile that runs around the footing and foundation. You have to pay attention to, a few of the places where you could get leakage. For example, if the drain pipe comes up into a window well, there's some special care you have to take with the window well so you don't get excessive air leakage and you actually get your pressure field extension. But that's more of a mitigating an existing building, and that's what the CGSB 012 document gets into a lot of details. So, yeah, um, I've seen a sump pit depressurization system spec'd on a job that I was working on for new construction. So wouldn't use it in new construction because it doesn't necessarily conform to code and it causes a lot more grief. So we abandoned that and put in a system that I helped design.
Thanks, Bruce. Alex has a question here. Just to confirm, this requirement is now a part of the OBC NBC, or is it yet to be added?
No, it's in OBC. If you go and you look up those code clauses that I talked about in OBC and NBC, they are there. They've been there for quite some time. Even if you go back to OBC 2006, it's been in there. So this is a requirement. So it has been impossible to build a building without radon resistant control in Ontario and meet code. It's been impossible to do that since at least 2006.
Thank you. Stan has a question here. For a two-story apartment without a basement, what route do you take to mitigate below slab radon through each divided unit question?
Basically the same processes we've just talked about here. You do all those key components to build something that's radon resistant. And this, you're talking about mitigation though. So I want to make sure that I'm not talking lingo. Mitigation is if the existing building has an issue, right? So again, that's a different standard, a different process, and that was covered more in webinar 2. But depressurization is probably your best bet. I've done lots of apartment stories, multiple levels in townhomes where we put in all the same requirements for radon resistant construction that we just went over today to manage that. The question that comes into play for residential units or multi-unit residential units and townhomes is, can you treat the building as a whole, or is each individual component or each individual unit under its own legal requirement to put in its own system? So there's some challenges there, and I'd be happy to talk to you about that in more detail. But the mechanisms and the principles of controlling radon are the same, no matter what the building construction is like, really.
Thank you. Robert has a question here. Is the code, sorry, Bruce, code if not enforced by a municipality, the builder still has liability under Tarion?
Yeah, the municipality could potentially have liability if they didn't enforce construction of the building in conformance with the code. And particular if it's caused cancer that, somebody's going for as much money as they can. But if the municipality did follow the resistant construction and did make sure the building was built to that, the builder is still responsible under Tarion for residential. You can't get out from underneath that, right? So, but if you've built in accordance to code and the building tests high, your fix is really easy. It's really easy because that's how it's been designed, right? So ideally what would happen is you built radon resistant, the homeowner tests their home, they say, hey, my radon's high. And you go, oh, okay, we built radon resistant. We'll send somebody out there. Somebody goes out, puts in a fan, retests, you're done. Problem solved. That's how it's meant to work, right? But the builder's still responsible for that. But if the builder's smart, they add on the cost of having to put a fan in that house regardless. And then if they do have to put a fan in that house, it's covered. They've already got the money for it. If they don't, well, they make a little extra. But it's all put in there already. It's not coming out of their profits. But yes, builder's responsible for Tarion claims. Yeah.
Wonderful. Thanks so much, Bruce. So I'm going to put Bruce's contact emails in the chat here and just send this to everybody. And also just to know that ECHO is going to be producing a lot more of these webinars. So please, if you could take a few minutes at the end to answer that survey and give us an idea of what you want to learn about. We want to make these webinars valuable for you. You can follow us on LinkedIn, and that means you'll get all of the notifications when we've got new webinars, new offerings, things like that for you. We have hit 2 p.m. So thank you so much for everybody coming today and to the whole series. If you've been with us for the entire thing, we hope you found it valuable. Enjoy the rest of your Wednesday. Take care.
Thanks, everyone.